Hey everyone, welcome, I am Amjith, and today I am gonna share with you Electro Pneumatic Actuator. Electro pneumatics is now commonly used in many areas of industrial low-cost automation. They are also used extensively in production, assembly, pharmaceutical, chemical and packaging systems. There is a significant change in controls systems. Relays have increasingly been replaced by the programmable logic controllers in order to meet the growing demand for more flexible automation. Electro-pneumatic control consists of electrical control systems operating pneumatic power systems. In this, solenoid valves are used as interface between the electrical and pneumatic systems. Devices like limit switches and proximity sensors are used as feedback elements. Electro-pneumatic control integrates pneumatic and electrical technologies, is more widely used for large applications. In electro-pneumatics, the signal medium is the electrical signal, either AC or DC source is used. Working medium is compressed air. Operating voltages from around 12 V to 220 volts are often used. The final control valve is activated by solenoid actuation. The resetting of the valve is either by spring, single solenoid, or using another solenoid, double solenoid valve. More often the valve actuation reset is achieved by pilot-assisted solenoid actuation to reduce the size and cost of the valve. Control of electro-pneumatic system is carried out either using combination of relays and contactors or with the help of programmable logic controllers, PLC. A relay is often used to convert signal input from sensors and switches to number of output signals, either normally closed or normally open. Signal processing can be easily achieved using relay and contactor combinations. A programmable logic controller can be conveniently used to obtain the outputs as per the required logic, time delay and sequential operation. Finally, the output signals are supplied to the solenoids activating the final control valves, which controls the movement of various cylinders. In electro-pneumatic actuators, the current in the solenoid is converted into pressure using the arrangement shown above. When an electrical actuating current of 4 to 20 mA is passed through the solenoid, it attracts the flapper fixed on a pivot. So, when the solenoid is activated, the flapper moves as per the magnitude of current through the solenoid, which will control the opening of the nozzle. Depending on the opening and closing of nozzle, the pressure signal is varied between 3 to 15 pounds per square inch. When the electrical signal in the solenoid is 4 mA, the nozzle output is minimum, thus the pressure signal is maximum, 15 pounds per square inch. When the current signal in the solenoid is maximum, that is, 20 mA, the nozzle is opened to maximum, leading to maximum fluid flow through the nozzle and thus minimum pressure, 3 pounds per square inch, of the pressure signal. The greatest advantage of electro-pneumatics is the integration of various types of proximity sensors, electrical, and PLC for very effective control. As the signal speed with electrical signal can be much higher, cycle time can be reduced and signal can be conveyed over long distances. In electro-pneumatic controls, mainly 3 important steps are involved: signal input devices, signal generation such as switches and contactor, various types of contact and proximity sensors. Signal processing, use of combination of contactors of relay or using programmable logic controllers. Signal outputs obtained after processing are used for activation of solenoids, indicators or audible alarms. 7 basic electrical devices used in electro-pneumatic actuators are: manually actuated push-button switches, limit switches, pressure switches, solenoids, relays, timers, temperature switches. Push-button switches. A push-button is a switch used to close or open an electric control circuit. They are primarily used for starting and stopping of operation of machinery. They also provide manual override when the emergency arises. Push-button switches are actuated by pushing the actuator into the housing. This causes set of contacts to open or close. Push buttons are of 2 types. momentary push button, return to their unactuated position when they are released. Maintained contact or detent push button, has a latching mechanism to hold it in the selected position. The contact of the push buttons, distinguished according to their functions: I. Normally open, No, type. 2. Normally closed, NC, type. 3. Changeover, CO, type. Limit switches, any switch that is actuated due to the position of a fluid power component, usually a piston rod or hydraulic motor shaft, or the position of load, is termed as limit switch. The actuation of a limit switch provides an electrical signal that causes an appropriate system response. Limit switches perform the same function as push-button switches. Push buttons are manually actuated, whereas limit switches are mechanically actuated. There are two types: classification of limit switches depending upon method of actuations of contacts. I. Lever actuated contacts. 2. Spring-loaded contacts. Pressure switches. A pressure switch is a pneumatic electric signal converter. Pressure switches are used to sense a change in pressure, and opens or closes an electrical switch when a predetermined pressure is reached. Bellow or diaphragm is used to sense the change of pressure. Bellows or diaphragm is used to expand or contract in response to increase or decrease of pressure. Figure 1.3 shows a diaphragm type of pressure switch. When the pressure is applied at the inlet and when the preset pressure is reached, the diaphragm expands and pushes the spring-loaded plunger to break contact. Solenoids, electrically actuated directional control valves, form the interface between the two parts of an electro-pneumatic control. The most important tasks of electrically actuated DCVs include switching supply air on or off, extension and retraction of cylinder drives. Electrically actuated directional control valves are switched with the aid of solenoids. They can be divided into two groups. Spring return valves only remain in the actuated position as long as current flows through the solenoid. Double solenoid valves retain the last switched position even when no current flows through the solenoid. Relays. A relay is an electromagnetically actuated switch. It is a simple electrical device used for signal processing. Relays are designed to withstand heavy power surges and harsh environment conditions. When a voltage is applied to the solenoid coil, an electromagnet field results. This causes the armature to be attracted to the coil core. The armature actuates the relay contacts, either closing or opening them, depending on the design. A return spring returns the armature to its initial position when the current to the coil is interrupted. Timer or time delay relays. Timers are required in control systems to effect time delay between work operations. This is possible by delaying the operation of the associated control element through a timer. Most of the timers we use is electronic timers. There are two types of time relay. I. Pull-in delay, on-delay timer. 2. Dropout delay, off-delay timer. Temperature switch. Temperature switches automatically senses a change in temperature and opens or closes an electrical switch when a predetermined temperature is reached. This switch can be wired either normally open or normally closed. Temperature switches can be used to protect a fluid power system from serious damage when a component such as a pump or strainer or cooler begins to malfunction. Electro-pneumatic actuator can be briefed as integrates pneumatic and electrical technologies, consists of electrical control systems operating pneumatic power systems. The signal medium is the electrical signal, either AC or DC source is used. Working medium is compressed air. In this, solenoid valves are used as interface between the electrical and pneumatic systems. That is, the final control valve is activated by solenoid actuation. Operating voltages from around 12 V to 220 volts are often used. Devices like limit switches and proximity sensors are used as feedback elements. More widely used for large applications. Types of actuators and their characteristics.